Hello and welcome to Noel's Retro Lab. Today we're going to continue looking at the CB2, which is a microcontroller configured to run as a basic microcomputer, a little bit like the computers from the 80s. Specifically today we're going to look into connecting it to a PC through the serial port, which is something that we didn't manage to do the last time, and then we'll look at some of the other features that it offers. This is the USB to serial cable that we saw last video that I couldn't get to work because both this connector and the CB2 connectors were male. But fortunately, I just got an adapter and it's a female, so we can plug this in here and convert it over to a female connector, and this should plug straight into the CB2. The reason this is covered in electrical tape is that I actually opened it up to make sure that there was nothing weird going on. I'm not going to show it here just because there were some pieces inside and I don't want to follow them over, but it's a completely straightforward connection. The only weird thing is that if you look at it, so this side is the one with 5 holes and this one is the side with 4 holes. But if you flip it over, this is 4 and that's 5. That's why I was really confused. So I opened it up and it turns out that, yeah, they're actually connecting the ones in this row with a metal piece that goes down and then connects to the bottom row. So they're all connected as they should. So this is not a null modem connection. This is just a regular connection. So we should be able to connect the PC to the CB2 now. First thing we need to do is put some jumpers right there so we can select whether we're going to use a regular serial connection cable or a null modem one. So they're hard to read as usual, but it looks like null modem would be connecting those two and regular cable would be connecting the next two. Let's go ahead and put some pins in there so we can put a jumper in the correct location. This particular cable came with a driver, so that's really handy. That way I install that and Windows can recognize it as a serial port. And there it is. It shows up as USB to serial COM3 port. Okay, let's plug it in the serial port. And here we are, ready to test it. For this, I'm going to use the old HyperTerminal program. There are better terminal programs out there, but this particular one was recommended in the CB2 page, so I figured we might as well start there. So we need to configure it for 2400 baud, no parity, 2 stop bits, and no flow control. I need to make sure that on the CB2 side, it's configured correctly. So yeah, 2400 baud, and we want the simple serial in and out. We'll see later what it means. And we're ready to test it through the CB terminal. Now I'm typing some keys on the computer and yeah, that's not looking good at all. Just in case, I'm going to switch modes so I can see what I'm typing. And now I'm typing on the CB2 and yeah, it just comes out as weird characters and same thing if I type on the computer. So something isn't right. So when this happened, I actually went ahead and I checked all the connections related to the transmit and receive pins and connectors on the board, and everything seemed to be fine. I also double checked the adapter and again, it checked out. Then I reached out to Cos, the person in charge of the project, and he suggested that I look into the voltages generated by my USB to serial adapter. And that is when I learned the difference between RS-232 and UART. Ever since the days of the early PCs, I used to refer to serial cables as RS-232. I always assumed that it had to do with the shape of the port, but that was only part of it. First of all, RS-232 stands for Recommended Standard. How about that? I had no idea. In particular, the standard says that receive and transmit are sent over 2 different lines and that there are 2 voltage levels. The negative voltage is usually -3 to -15 and positive voltage is anywhere from +3 to +15, and that in the idle state will hold the negative voltage, but also a logical 1 is actually negative voltage and a logical 0 is a positive voltage. And then we have the UART, which stands for Universal Asynchronous Receiver Transmitter. UART is more of a hardware piece rather than a standard, which takes care of serializing and reassembling data to communicate serially. UART doesn't define specific voltage levels, but it definitely defines idle as high, but then a logical 0 is low voltage, so usually it's 0 volts, and a logical 1 is high voltage or 5 volts. Unfortunately, I wasn't the only one who wasn't totally clear on this distinction, so whenever you get a device that claims to be RS-232, you really need to check if they mean the connector shape or the voltage levels it produces. I suspect that might be our problem, so let's measure them. Okay, so here we have the CB2 wired up so that the oscilloscope is looking at the transmission pin on the serial connector, and then it's grounded on the ground pin, so pin number 5 of the serial connector. And initially what we're seeing is that the default voltage is actually really low. So this is each square is 2 volts. So this is -2, -4. That's like -5 volts, which is exactly what you expect out of the RS-232 standard. And now if I press a key, it's going to send the code for that key serialized. And there we go, we get something like that. And notice it jumps way up to, again, +5. So yeah, it has a total of 10 volt differential. That's what the RS-232 expects. So yeah, this is behaving exactly the way you would expect. But the ATMega microcontroller doesn't interface directly with RS-232 signals. Instead, it has some added circuitry to invert the signal and bring it down to a 0 to 5 volt range. Okay, so now in addition to looking at the transmission line on the serial port, we're looking at the transmission, a TX1 pin on the microcontroller itself. There we should see the same serial pattern, but before the amplification. So the first interesting thing is that it looks like the default voltage is 5. So when there's no activity, it's 5 volts. And when we send something, there you go. We see the same kind of pattern, just reversed and going down to 0 volts. So it's quite different from what comes out of the RS-232 as far as voltages. And now for the other half of the test, which is we have the computer with the USB to serial cable. And again, we're looking at the ground and transmission line. And when I press a key, we are sending some serial codes again, depending on which key I press. And this is very different. This is definitely, when I'm not sending anything, idle is at 0 volts. So that is definitely not RS-232, but it's also not the UART that the microcontroller expects. Otherwise, it would be idle would be at 5 volts. And when we press the key, the sort of logical true becomes 5 volts. So to make things easier to be able to connect things to the receiving and transmission lines, I'm going to solder another row of pins right there. So that way we'll be able to bypass some of the amplification and resistors that deal with the RS-232 and just go straight there. So I noticed something else that is a little bit more worrisome, which is I think the signals being sent by the computer along the USB to serial port were slower than the ones generated by the CB2. So let's run some tests. I have here the computer hooked up to the CB2. The CB2 is not even plugged in. I've just hooked up in here because it's a convenient way for me to hook up the oscilloscope, so I don't have any bridges right there, and I have the probe hooked up to the transmit pin and then to ground. And then in the computer, I have hyperterminal running configured at 2400 bauds, just like we had the CB2 earlier. So when I send a character like W, like we were using earlier for a test, yeah, that seems really slow. Very, very slow. This is the signal coming from the CB2. And let's assume the first pulse is 1 bit. The scale is 1 grid is 800 microseconds. So that looks a little bit more than half, so maybe 500 microseconds. So 1 divided by 500 microseconds, so the inverse of that, gives us 2000 bits per second, which is approximately the 2400 BPS that we were expecting. And now the signal coming out of the PC, if we take the first pulse to also be 1 bit, we notice the scale is very different. The scale is 2 milliseconds per square, so that's a little bit less than 3 milliseconds, let's say 2.5 milliseconds. So the inverse of that is only 400 BPS. What a difference. So what happens if I change it to a different speed? So if I set it to 4800. Okay, it's now configured to 4800, and yeah, that is not just twice as fast. That is way faster. That seems about right. That seems faster than what we're seeing on the CB2, but this is like 10 times faster than what supposedly was 2400. And what about 1200? Okay, there we go with 1200. And yeah, that's very slow. That is not 4 times slower. Ironically, that seems maybe faster than the 2400 that we're seeing earlier. But yeah, that seems wrong. Also, okay, this is bizarre. I'm pressing the same key. I'm pressing W repeatedly, and it's sending different pulses. That cannot be good. Sometimes it sends a short pulse to start with, sometimes it's a wider one, sometimes it's a third one. So this is really making me think that the electronics inside this USB to serial connector are just not working correctly. And maybe this is okay at 4800. It looked okay on the oscilloscope. Unfortunately, the CB2 only seems to run at 1200 and 2400. Now, there's some other options in the menu, so maybe we can explore that and see if we can make something work. In the configuration page of the CB2, we can change the serial speed. And it looks like we can change from 2400 to 9600, but then there's a 1 that changes into a 2. That means it's the second port. It's not the normal port that we're using. And same thing with the 38.4K, and then it goes back to 1200. So in port 1, we're out of luck and we can only use 1200 or 2400. I actually managed to get another USB to serial cable, and just in the nick of time for the video. Let's give it a try and see if that's a problem with all of them or if this one works correctly. So I've hooked it up to the CB2, but again, it's just not connected. I'm just measuring the signals coming out of the transmit line. And okay, right away, this looks very different. This is a true RS-232. I'm not transmitting anything, and the signal, it's right sitting at -6. And when I press a key, there you go. It goes to +6. So it has the wide voltage range you would come to expect. And it's getting all the way to +6 over there. So, and it's positive with the logical one. So that looks really good. Let's connect it and see if it just works right away. Okay, and let's see if I get... Yeah, there you go. Great, and from here, yep, they show up great on the other terminal. So this is the way it should have worked from the beginning, and we just had a defective cable. But okay, that's good. That's much simpler. Okay, so I'm gonna go to one of the slots where I want this. This is where I was doing my test earlier. Let's do a receive. Let's see, so control F3. Right, receive program. Yes. Okay, now it's waiting. And I'm just gonna paste it straight in the terminal. There we go. There we go. Did that work? It looks okay. Let's run it. Save it first. Save, yes. And let's run it. There we go. Oh, I don't know the keys. Oh, there you go. Awesome. So now we can really do some work on the computer and pass it over to the CB2 pretty easily. And that's going to be a lot more convenient than trying to type it in the editor, which wasn't bad, but it was just limiting. So one last thing about the serial communication with the CB2, and then after this one, we're done. Sending programs from the computer at 2400 baud, it's kind of slow. I mean, it takes a while to send all 100 lines of a basic program. So I thought it would be great to take advantage of the other feature that the CB2 has, which is it has another communication port. If you look very closely in the PCB, you'll see there is an RX1 and TX1, but also an RX2 and TX2. And that's why we have those different numbers in the speed menu. When we switch from 1200 to 2400, it says 1, so that refers to it's going to be using port 1. And then when it switches to 9600, it's port 2. It turns out I had this USB to serial interface as well. And this one looks like it's a UART one. So we could connect this directly to port 2. Let's give that a try. It actually has a 5-volt connector, so we could power the CB2 directly from it. We start by connecting the transmit and serial lines to the second port, and we need to cross those over, so the receive from the serial interface goes to the transmit of the CB2 and vice versa, and then we connect the power and ground. And now we power everything with a USB cable and connect it to the computer, and we're ready to go. On the CB2 side, we need to set the speed to 9600 baud, and then we need to change the serial in-out from simple, which means RS-232, to standard, which means it's accepting UART-like voltages. Okay, as a first test, I'm going to send this program over to the computer, and yeah, that was really quick. We got the full listing on the PC. And now I'm going to try it the other way around. I'm going to send a different listing to take over this slot on the CB2. So yes, and need to paste it on the terminal. And there we go. Although this is really slow. Yeah, this is very slow. This is not 9600 baud. That's very weird. We need to look a little bit more into this. All right, so let's see what exactly is happening with the transmission line. So the interesting thing is that it was getting the characters, but it was just getting very slow. So we're going to start this again. Transmit, yes. Let's look at the... Oh. All right, that's very interesting. This is an individual character being transmitted, and that's the speed that we expect from 9600 baud based on what we saw earlier. But then there's all this delay that is just waiting in between characters. I don't know why it's waiting that long. I wonder if it has anything to do with the program itself. I mean, it could be the driver, a really bad driver for this. It could also be the terminal program. Let's try a different terminal program. Okay, I've connected TerraTerm. Hopefully this one is different, and paste. Oh, there you go. It just went right away and it sent the data really quickly. Let's see if I can catch it in the oscilloscope. Yeah, look at that. There's no delay between the characters. So it was just hyper-terminal that for whatever reason, maybe this is a setting that I can change, but for whatever reason, it was adding a pretty big delay between characters. Okay, that's great to know. Let's do one final test. Let's try sending data at the highest speed that the CB2 supports. So I'm going to switch over to 38K and let's receive a program. Yes. And wow, it detected that I sent something, but then it just says okay and it doesn't show anything. What if we send the program to TerraTerm? Send, yes. Oh, and we just get garbage on the screen. Well, it is a big jump from 9800 to 38K, so I don't know, maybe this guy doesn't support that speed. I mean, the driver does because it lets us configure it that way, but well, I think 9600 is pretty good for the amount of data that we're going to be transferring back and forth. One of my main complaints last time I looked at the CB2 was the 100-line limit on basic programs. I imagine that comes from the limitations of the ATMega microprocessor, although I don't really understand why we can't get around it with a few minor changes, so I might have to look into that in the future. But in the meanwhile, there's a way to let people create larger basic programs, and that's with the call keyword. It's very similar to go sub, to go to a subroutine, but it indicates the program slot first, and then the line number to jump into. There are a total of 8 program slots on the CB2, so that extends it quite a bit. The thing that is a bit weird is that it uses an absolute program position instead of a relative one. So if a program is designed to be in 1, 2, 3, you can put the first one anywhere you want, but then the second and the third have to be in slots 2 and 3. But it's better than nothing. So let's give it a try. There's already a program in the CB2 website called 2048, written by Wolfgang Schmidt, that uses 3 program slots. The game is based on the original Threes game, but with powers of 2, which is a pretty common clone. It looks pretty simple on the surface, but the rules are relatively complex, so it needed more than 1 program slot. Here, for example, we can see how it calls a subroutine in a different program. So let's go ahead and load it up in the 3 slots now that we know how to communicate with the PC finally. And there you go. It's not particularly visually sophisticated, but it's great that we can get something of this level of complexity in the CB2. So this is a perfect example of what you can do by chaining multiple program slots to create a more complex basic program. So what is my wish list for the CB2? The main thing by far would be more static RAM. That would mean probably a new microcontroller and an updated firmware. That would allow you to edit larger basic programs without the limitations we have right now. And as a side effect, it would allow you to have more data during the runtime of the program, which would allow maybe for more complex basic programs. So that would be fantastic. The next thing is that the sound on the CB2 is really basic. I think it would be really fun to have an expansion that connected some kind of sound chip, maybe like an AY sound chip, to the CB2 and exposed that sound generation capabilities to the microcomputer. That might even be something that I might want to tackle in the future because it sounds like a really fun project, and it would have forced me to learn about assembly programming on the CB2, which is something you can do and we haven't talked about so far. So that's it for today. I hope you enjoyed the video. If so, please give it a thumbs up and subscribe to the channel. Until next video, see you then.